Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARHAN HAQIMI bin ABDUL LATIFF. Today, I will present to you about the introduction of our group project. The engineering geology subjected, which is required for students in pursuing civil engineering programs at university. To meet this criteria, students need to go to field, do kind of rock classification, RMR, which is rock mass rating, and examine the deep angle and deep direction at Sungai Lembing. For the destination that we go at Sungai Lembing Pahang, we go for Sungai Lembing Museum, Sungai Pandan Waterfall, Sungai Lembing River, Sungai Lembing Tunnel or Kolong, and we go for at Panorama Hill. At Sungai Lembing Museum, we do some quizzes. Sungai Pandan Waterfall, we go the data for the deep angle and deep direction. We use the Brandt compass. At Sungai Lembing River, we do the classification of rocks. At Sungai Lembing Tunnel or Kolong, we do a RMR for that place. At Sungai Lembing, we stay for 3 days and 2 nights there.
Assalamualaikum and hi, my name is SYAFIQAH RAHMAN, number matric DF210034, and I will continue the presentation about methodology of this project. As for the equipment, we mainly use Bruton compass and rebound hammer throughout our project. We use the Bruton compass to determine the type of geological structure occurring on the rock mass. This equipment was used to obtain the deep direction and deep angle of discontinuities of the rock. As for the rebound hammer, the result obtained will be used to obtain the compressive strength of the rock. Procedure that being carried out in air terjun Sungai Pandan was obtaining 30 sets of discontinuity data while observing some geological structure at bottom of rock which were joined and fractured. We calculate the discontinuity of the joint, the rocks, to determine the deep angle, deep direction, and strike of the rocks. Meanwhile, rock mass rating for rock mass classification was conducted at an unexplored tunnel located on the roadside near Sungai Lembing. Inside this tunnel, we are divided into several groups to do the task within the given period. There are 6 parameters used to classify rock mass using RMM system, which is an axial compressive strength of rock material, rock quality designation, spacing of discontinuities, condition of discontinuities, groundwater condition, and orientation of discontinuities. That's all from me. I will pass to the next presenter. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is AYUNI binti KAMRI, matric number DF210071. Now I want to present about result at air terjun Sungai Pandan. This is air terjun Sungai Pandan. What we do at air terjun Sungai Pandan is collected data for the air terjun Sungai Pandan. The team should collect 30 sets of discontinuity data. The respective tools are required for discontinuity identifier, Bruton compass, A4 writing board, pencil, and A4 paper. In this air terjun Sungai Pandan must taken the rock's deep angle and deep direction. This is Bruton compass. After that, I want to explain about discontinuity. Discontinuity is a plane as well as the surface in a site or rock mass which highlight a transformation in physical or chemical properties. An example of discontinuity like bending, foldation, joint, cleavage, fracture, crack, and the others. After that, in discontinuity required deep angle and deep direction data. Next, I will show the 30 set of discontinuity data we have collected at air terjun Sungai Pandan. What we do from this data have 4 steps. Firstly is plotting tool for this data like that. Second, we have counting data with using cascade deck like that. Third step is contouring for this data like that. Last step is plotting grade circle for this data like that for grade 5 pole. The pole which have a 5 have deep direction and deep angle. For the summary, what we do have like that. Mode of failure at air terjun Sungai Pandan, what we have is 3, planar, wedge and toppling. This is summary we get in this air terjun. That's all from me. I pass this presentation to the next presenter.
Assalamualaikum and hi. My name is Haziq bin HASSAN. Number matrix DF210065. So today I'll be presenting about our results of quiz at Sungai Lembing museums and identifications and classifications of rocks that we got from our Sungai Lembing trips. So anyway, let's get started. So first of all, I will discuss about identifications and classifications of weathering grids of rock outcrop. So rock is naturally occurring and cohesive aggregations of one or more minerals according to geology. These aggregates are the fundamental of solid earth and generally create volumes that are identifiable and mappable. So according to the process that led to their creations, rock are often categorized into 3 basic categories, which is these classes includes igneous rocks, sedimentary rocks, metamorphic rocks that are discovered along the Sungai Lembing. The collected data as shown as table, which is the identifications and classifications of rock according to their texture, color and chemical compositions, which is this rock were identified by using bare hand and naked eye, which is these tables help to identify whether these rocks are under unweathered or weathered conditions as they are exposed to the environment at along the Sungai Lembing. So let's move on with the tables. For the first classifications of rock, I'll be showing sedimentary rocks classifications first. So these sedimentary rocks are classified based on sedimentary classifications chart, which is these rocks are classified with characteristics as such as rock name, texture, mode of origins, compositions of rock, classifications and sketch. So I will be showing the chart over here, sedimentary rock chart right here. So okay, let's move on with the table, which is for the first rock that we obtain is shale, which is the texture is clastic fine grain, which is 1/256 to 1/16 millimeters. Mode of origins, which is mechanic. Compositions of rock, which is quartz grains. Classifications of rock, which is mechanical or bioclastics. So these are the rocks, the sedimentary rocks that we obtain. For the first, the second stone, which is the second rock, which is sandstone, which is the texture is clastic medium grain, which is 1/16 to 2 millimeters. Compositions of rock, which is quartz. Classifications of rocks, which is well sorted sandstone. So this is the sketch for these rocks. So we move on with the igneous rocks. So we move on with the next classes of rocks, which is igneous rocks. These igneous rocks are classified based on igneous classifications chart. These rocks are classified with characteristics such as rock name, texture, mineral compositions, chemical compositions, origin and sketch. So I'll show for the first rock that we obtained at Sungai Lembing, which is the granite. Granite with the texture of medium to coarse, which is pheneric. The color of this rock, which is like less than 25% dark minerals. Mineral compositions, which is it consists of quartz, hornblende, orthoclast, plagioclast, biotite, muscovite. So chemical compositions, which is the content for these rocks, which is acids more than 65%. The origins of this rock is intrusive, which is I'll be sure this is our rocks for granite. Oh, to forget, which is I'll be show these charts for igneous rock classifications. So I'll be show right here. Okay, so let's move on with the next type of rocks, which is the metamorphic rocks. So the last one, which is the metamorphic rock classifications. So these three types of rocks using their own chart that I'll be show in every part of this video. So these metamorphic rocks are classified based on metamorphic classifications chart. These rocks are classified with characteristics as such: rock name, structure, grain, mineral compositions, parent rock, metamorphic type, and sketch. So first for the first rock, which is the rock name, phyllite. The structure is schistose. The grain, which is fine grain. Mineral compositions, which is mica or quartz. Parent rock, which is shale, mudstone, or tuff. Metamorphic type, which is increasing regional. So these are the rocks that we obtained at Sungai Lembing, which is for the metamorphic rocks. So that's all from me. So I'll be showing the rocks that we obtained at Sungai Lembing and the conditions of Sungai Lembing on my trip. So this is the extra videos for you to watch. So I'll be show right here. So for the last part of my presentations, and I will be showing the results of activities at Museum Sungai Lembing. So every group were given a quiz at Sungai Lembing Museum that include questions regarding about the Sungai Lembing Tunnel and the Pahang Consolidated Company Limited (PCCL). The solutions all of the questions that discovered at the museum are presented as such. So this is our answers for a quiz at Sungai Lembing. So I think that is all from me, and I'll pass for the next presenter for the next presentations. Thank you very much.
Hi, I am Mohamad ASRAF bin NORDIN. I would like to present to you about the rock mass rating or RMR project that we had been done in our field trip at Sungai Lembing. This project certainly had been successfully investigated or determined at Kampung Kolong Pahat, which is at Kolong Tunnel. The RMR system is based on these two data or two table rock mass rating system by after Brzezinski in 1989. And in this system, we have 10 steps that we need to follow by using the procedure to have the rock mass rating system project successfully done. So the first step is select an outcrop. Therefore, due to the limitation during the field trip in the tunnel, so we only choose or select 1 meter an outcrop for the tunnel at the tunnel wall. And step 2 is determine the uniaxial compression strength. And to determine the uniaxial compression strength, we need to find or we need to collect 9 data at the tunnel wall by using rebound hammer. And we already gathered 9 data with the mean value or average value is 20.22, and therefore by using the graph given, we can find the compressive strength is at 14 Newton per millimeter squared. By using the compressive strength data, we can conclude the compressive strength is between 5 until 25 megapascal, which is in the rating table. The rating for the uniaxial compression strength is 3. On the next step is RQD, or rock quality design. In this step, we use the formula RQD is equal to 115 minus 3.3 JV, which is JV is equal to 1 over S1 plus 1 over S2 plus 1 over S3 plus 1 over Sn, which means N is the number of joint set. And in this rock quality design that we had been successfully done, we had 8 joint sets and the average spacing that we had been calculated. Therefore, we calculate the JV with the value is 21.167, and we enter the value into the equation RQD is equal to 115 minus 3.2 times with 21.167, which we already get the RQD at 45.1489. Therefore, we can conclude the RQD is in between of 25% and 50%. Thus, the rating is 8 according to the table of the RMR system. We go to the next step is on the step 4, spacing of discontinuities. To calculate the spacing of discontinuities, we just need to find the average or find the mean of the joint set of spacing discontinuities. And we can see here, we already calculated the spacing of discontinuities value at 0.4625 centimeter or 4.625 millimeter. And according to the table of RMR system, the spacing of discontinuities is less than 60 meter, thus the rating is 5. And we go to the next step, is step 5, condition of discontinuities. The condition of discontinuities, we already find the parameter, condition, and the rating by using the persistent, because the persistent condition is discontinuity length less than 1 meter. Therefore, the rate is 6 at 6. And the aperture, joint opening, the joint opening is 1 until 5 millimeter. Therefore, the rating is only 1 according to the RMR system. And the roughness, we already investigate the roughness of the tunnel wall is lichen-sided. Therefore, the rating is 0. And the infilling in the tunnel wall or gouge, the condition is soft filling less than 5 millimeter. Therefore, the rate is 2. And the weathering of the tunnel wall is moderately weathered. Therefore, the rating is 3. By this rating or this investigation, we can conclude the rating of condition of discontinuities is at 10 by the condition of the tunnel wall or the condition of discontinuities at the wall. Next, we go to the next step is step 6 or groundwater condition. And we had been determined the condition in the tunnel wall is dam condition, which the rating is 10 according to the RMR system. The next step is orientation of discontinuities. The orientation of discontinuities need to be observed and measured. Either it's parallel or perpendicular to the tunnel axis, and we had been determined the strike is parallel to the tunnel axis with dip 20 degree until 45 degree. Therefore, the strike and dip orientation is a fair condition, and the rating is -2, which is favorable. The next step is classification and total rating. The classification and total rating is actually we need to find the total of the rating from the step 1 until the step 7. And we had been gathered the point load index is rating 3, RQD at 8, spacing of discontinuities at 5, condition of discontinuities at 10, groundwater conditions also at 10, and orientation of discontinuity at -2. Therefore, the total is 34, which is in the RMR system, we can conclude the tunnel wall is actually a poor rock. Therefore, that by that information, we go to the next step, which is step 9, is excavation and tunnel support determination. So, because of the poor rock and the rating of 34, therefore we can conclude we need to have top heading and bench method. Excavation of this tunnel with 1 until 1.5 meter advance in top heading. The support concurrently with excavation is 10 meter from face, and we need to have systematic bolt or use systematic bolt with 4.5 meter long space 1.0 until 1.5 meter in crown and walls with wire mesh. And then we also need to use the shotcrete 100 until 150 millimeter in crown and also 100 millimeter in sides. And lastly, we need to use the steel sets, which is light to medium rib space between space in 1.5 meter. And by using these 6 characteristics, we can have the excavation and tunnel support to ensure the safety of the workers or the people inside the tunnel. By using this information, we go further to the next step or the last step, which is the sketch step. And by using SketchUp, we had sketched these 2 diagrams, which fulfill the 6 requirement or the 6 required structure in the tunnel. So the steel sets required is light to medium rib space 1.5 meter, which is required. And the suggested bolt is used in the tunnel, which is systematic bolt 4.5 meter long space 1 until 1.5 meter in crown and walls with wire mesh. And then we also use the shotcrete required 100 until 150 millimeter in crown and also 100 millimeter in sides. And then the top heading and bench method is being used, and the excavation of this tunnel shall be 1 until 1.5 meter advanced in top heading. The support also must be installed concurrently with excavation 10 meter from face. Therefore, this is the last sketch that we had been successfully done in this project of RMR for our field trip. Hi, I am Mohamad ASRAF bin NORDIN, and I would like to present to you about the discussion of our project from our field trip. According to our field trip, we had successfully done 3 investigation or 3 experiment or 3 projects. First project is about the classification of the rocks, and this classification of rock had been successfully done because we had determined or classified 3 types of rock, which is sedimentary rock, igneous rock, and also metamorphic rocks. And the second project or the second investigation that have been done is rock mass rating at the Kolong tunnel at Kampung Kolong Pahat in Sungai Lembing. And this RMR system also had been successfully done because it had been analyzed and been determined the rating. And finally, we found the sketch of the RMR tunnel or the excavation that, and support system for the tunnel. And the last part is we find the mode of failure by determining the set of discontinuities by determining or reading the joint side and also the deep angle and deep direction, and then sketch on the tracing paper. Therefore, in these 3 projects that we had been successfully done, this actually very important and very crucial for civil engineer, and not just civil engineer actually, because it's for geology engineers to learn how to inspect and how to do a field trip. And it is very important for the inspection, designing, structuring, and building for the pavement roads, and also building the building for civilization. Therefore, this is very important for us, for civil engineer and geology engineers to learn and to experience the field trip, to know or to determine how to done this project according to the procedures.
So we jump to the conclusion. The conclusion that can be made is this trip is beneficial for students in order to learn the geological things. Next, students also can learn on how to identify the types of rock based on their observation, which is at Sungai Lembing River. Next, the student also can learn on how to proceed the rock mass rating RMR at the Sungai Lembing tunnel, or we call it as a kolong. Then, the student also can learn the history of the Sungai Lembing, which is at Sungai Lembing Museum. Lastly, students also can learn about the Schmidt hammer and Brunton compass procedure to identify the hardness of the rock, which is for the Schmidt hammer test, and Brunton compass we can also get the direction for the deep direction and the deep angle. That's all from me. Thank you.